everyone, Paul Tchaikovsky here from Pivotal. I just wanted to go through today how I currently deploy PKS on Google Cloud, as it's a little bit different to what most people do. So I use a Kubernetes operator, actually a pair of Kubernetes operators, to stand up the majority of my infrastructure. And then I use Tekton to do the actual PKS install. I have this all up on GitHub under this repo right here. And so let's actually go through it. Let's switch across to here's the same doc with all my stuff down locally. And so we'll just go through it. So first of all, you actually need a Kubernetes cluster. And so we're going to create a single node Google Cloud, Google Container Engine cluster. And I've actually already done that just to save some time. So if we do a get nodes, we'll see we have a single node Kubernetes cluster. And that saves us a little bit of time there. We're going to be using Helm 3, so we don't need Tiller. And so we need to start to customize it for our local environment. And we're going to do that with some environment variables we'll load into various places. So let's just go ahead and get those loaded up. Obviously my Google Cloud project ID and then the DNS that I have registered and managed by Google Cloud, which is going to register my DNS records for me. Next, we need a service account for our two operators. Now, I've already gone ahead and done this, so I will skip these steps, but you can basically just run these as they sit. And it should work for you. And you'll notice it's outputting the key file into a scratch directory. And that's a directory that has a git ignore file in it that's going to ignore anything you put in there, so you don't have to worry about random scratch files ending up in your Git repo. Next, we're creating some namespaces. So I'll go ahead and do that. You can see I've actually already done that because I needed to load up some secrets before we started. Then we have our secret right here, which I believe I've already created. Let's look, that's in this namespace here. So let's look at that, get secrets. Yeah, so I've already created that GCP key. And then we need to actually download GCC itself. So GCC is the Google config connector, which if we look it up here, Google config connector. It is an operator created by some folks at Google Cloud to allow you to manage Google Cloud resources from inside of Kubernetes. It's a pretty good idea. It works really well. There's still a bunch of resources missing, which I need, but I kind of prop it up using an operator I wrote like 18 months ago that does more or less the same thing when I was starting to first play with this idea. And so I'm using GCC where I can, because obviously that's the way forward. It's officially supported by Google. But then I'm using my own operator where we're missing some stuff still. So it's pretty straightforward. We can look at the resources. So basically all of these are resources that have CRDs. So we can say look at compute address, and you can see there we have our Google YAML, our Kubernetes YAML to deploy or create compute addresses inside of GCP. So we're basically wrapping that stuff to deploy our infrastructure. Right. So back to where we're at. So we need to download GCC. Now you need to actually be registered for their beta or alpha for this to work. But if you are, you can download this. If not, that documentation I was just showing you tells you how to contact folks to make that happen. Otherwise, just hit me up and I can get you in contact with them. So here we're just going to download it and untar it and then apply it. And I think I've already untarred it. So let's look at Scratch install bundle. So you can see there we already have it. So you have the CRDs and then the actual deployment YAML itself. So we can go ahead and let me just fix that so it works. So that's going to go ahead and deploy it. So you can see quite a few things getting deployed, CRDs and whatnot. So while that's happening, we also then need to install my GCP operator, and we have a CRD, and then we'll use Helm to actually install it. And we're going to install it into that same namespace just for simplicity. So let's go ahead and do that. So that's our CRDs finished from GCC. Here we install the GCP operator. Again, a bunch of CRDs and the operator. And then we can do get pods, and we'll see our stuff running. So there's our the Google config connector, and then there's my operator. So we want to look at them. We could logs. As you see, not much going on yet, but as I start creating resources, it will start doing stuff. So there we go. That's our 2 operators running, and they're going to do most of the heavy lifting. But I also want to install Certificate Manager. I don't like to use self-signed certificates where possible. So Certificate Manager gives me an easy way to create and apply certificates to Kubernetes resources. And so I'm going to go ahead and install this like so. So now we actually want to deploy Ops Manager, and so we have a values file, and then we can override stuff either in a separate values file, or we can override it at the command line. Generally speaking, you'll do it in a values file, but for the sake of this, we're going to go ahead and set it from the environment variables we've created. And it's creating it in a namespace named for our project ID, and that is what both operators are looking at. So they'll only install stuff that is being requested in that namespace. So we can go ahead and do this. So we're using Helm. I'll kick it off, and then I'll kind of take you through some of the templates in the Helm chart. Oh boy. All right, I'm back. So it looked like it just was taking a bit more time than I expected to set the CRDs up. So anyway, there's my Helm 3 install complete. So you can see there it is right there. And it's giving me a bunch of stuff to find out where my Ops Manager is. So we can go ahead and let's just grab this bit for now. And so you can see it's obviously working away. Let's try the compute address. Oh, that's US Central 1. So you can there see GCP has gone and is working on creating a GCP address for me. So while that's running, we can have a look at our templates up in the Helm chart. So here we have our Opsman Helm chart. Here we have our templates. And so let's look at the address, right? So we have, there's our API version. There's our kind. So compute address. Compute addresses. So there is our compute address that we've created. And you can see in the status, it has links, etc. here. So that's an example. It's pretty straightforward. It's an external address for the PKS load balancer. And the good thing about GCC is the spec that you use here is more or less the same as the API payload to the actual resource itself. So it's pretty straightforward. There are some exceptions for when you're, let's look at the network. So you can see here we create the network, right? And then down where we create sub-networks, you have this network ref, and that points to the Kubernetes resource that we created, the network that we created via the Kubernetes resource. And so generally when you have to refer to from one resource to another, you use a ref like that. And so you can see these are basically the standard addresses and stuff you would set when you're installing PKS. So you obviously have some compute subnets for Opsman itself as well as PKS. Here we have our compute image, so you can see we're pulling it from the GCP, the GCP storage bucket that contains the appropriate image, and that is actually basically you would get that from your PivNet for the app, which would be able to give you that URL. But you can see I've templated out the storage bucket and also the version just to simplify things. So anyway, there's a bunch of stuff going on there. You can see we're also creating certificates. So we have a certificate issuer, which is pulling from some template items for my email address, etc. And that has access to my Google Cloud credentials. It really only needs DNS management access, but I think this is an admin account for now. And then we have certificates, so this creates a certificate for Opsman, and this creates a certificate for PKS itself. So each of those will get real certificates. And then obviously we need to configure Opsman and PKS, right? And we do that via automation with Tekton later, but we need to build the configs. And so we're doing that as config maps, and we're passing it to this Tekton namespace. And that just lets us template out our various bits and pieces we need to send to the config, right? Otherwise it looks pretty much like a standard properties file for any Bosch release. Same for PKS config. You can see we have a bunch of stuff here. We have our plans. So here is where I should have actually used my own values file, and let me show you why. And I might upgrade the release and use them just so it makes it easier in a minute. So in my Scratch directory, I have a opsman.yaml, and you can see I've already set zone. I need to unset these before I do anything. And then you can see I have an add-on here, and this add-on is actually going to help manage the load balancers for my clusters. Basically, when each cluster comes up, we'll actually go ahead and create its own load balancer, and it will help me get to that. So that will simplify my life a little bit later on as well, and do most of the automation I need to access my clusters. So let's save that, and then let's go ahead and Helm 3 upgrade. We can just go ahead and values Scratch opsman.yaml, right? So this should go through pretty quickly. And then so let's have a look back at our chart. And let's look at PKS config. And so that was installing to this namespace here. So okay, and get CM. So you can there we see we have opsman IAS config, opsman PKS config. Let's have a look at this guy, CM. PKS. So here you can see we have the finished PKS YAML, basically the properties file for the BOSH release. You can see my certificates here are still blank, and that's because they'll get loaded in via the automation separately. Otherwise, it's kind of all filled out. If we look at that add-ons, you can see it's kind of hard to read because it's wrapped, but there's my add-ons, so that's going to be loaded into each of my clusters. All right, so if we pop back down here, Helm install opsman. So let's look and see if our stuff is available yet. So there's our PKS IP address. So let's stick that in the values file. And then what's our opsman? So get instance opsman. And so you can see here, my CRD actually knows to output the internal and external IP, so that's opsman itself. We can confirm with this, right? You're being redirected. So this is what we would expect in opsman. If we come here and we pump that in, HPS, this is what we would expect. Obviously, opsman installs initially with a self-signed certificate. So this is the basic opsman is ready to be configured. So that kind of tells us that the resources were all more or less created correctly. And so we can pump that IP address into here. And then we can run that Helm upgrade again. And the reason we're doing that is because now we have those IP addresses in there. It's going to actually create the DNS records for those two hosts. So if we look at gcloud DNS, manage zones list. So we have our managed zone called opsman, and then we can then look at record sets list zone equals opsman. So you can see it's created these two records. One for opsman, one for PKS. It's got a text record to explain that it came from the GCP operator. And this is one of the resources that we're creating with my operator rather than GCC, as is the instance itself. So that is more or less opsman installed. So now if we go back to our README, we can then deploy Tekton itself and then run our automation for deploying the rest, configuring opsman and the rest of stuff. So we need to obviously apply Tekton. I have it vended in here just in case they change stuff as they're working on it. I don't think their APIs are considered stable yet. So we can go ahead and do that. Clear our screen. So that's Tekton installing. There's a bunch of CRDs as well. And then next we need to create a bunch of secrets and config maps. I'm going to go ahead and do that. And you'll probably notice that I have some really bad passwords here. Obviously you would want to change these. There's no reason I couldn't have put these up in the Helm chart. I just for now wanted to have them really explicitly called out that these are the settings I'm setting. And you can even see for our PKS config, I'm actually setting not just our DNS for PKS, but also the version of PKS I want to install. So if later on I wanted to upgrade it, I could just update this config map and rerun just the PKS config task in Tekton, and that would upgrade it for me. So that's a super simple thing to do. Obviously, if you were making a major upgrade, you might need to update the PKS config map with any new Bosch release properties or anything. But for basic upgrades, that just updating that works. So let's go ahead, and the only thing I've already done is obviously it needs to talk to PivNet to download PKS, Bosch releases, etc. I've already provided this secret, right? So if we look at get secrets in here, you'll see that there's my PivNet auth, and you'll see that Opsman as the certificates have been created here as well, and so that's been done by the certificate manager, and will become super useful. So I can go ahead and run all of these, so up until here. Obviously the namespace already exists, I didn't need to redo that, but I did. All right. So that's that done. So now I have a bunch of config maps and secrets, right? Just a couple of extra ones: Opsman auth, PKS conf, PivNet auth, PKS config, Opsman auth, etc. So that's great. Now we have a bunch of pipeline tasks, pipeline itself, and then a pipeline run. So we'll go ahead and let's have a quick look at them. Let's install these, and we'll have a quick look at our tasks. So here's our pipelines. So our pipeline install PKS. Basically, this is a Tekton pipeline that calls a bunch of tasks and orders them. And so you can see I start with configure Opsman auth. When that's finished, I then Opsman cert, and then Opsman IaaS, PKS, and then PKS user. So Opsman auth is just loading in environment variables from my various config maps and secrets, and it's then running this Opsman configure command. So pretty straightforward, and this is going to set up my username, password, and encryption password, and then Opsman cert is going to do the same for the certificates, and it's setting in the environment variables for the Opsman target username, password that we've just set. As you can see here, it is going to then load up our certificates, and then it's then going to call this configure IaaS. This is going to load up config files and stuff. It's going to run a config file that's coming from a config map, and that config file is this, which is a fairly basic bash script. It's going to wait for Opsman to actually reply with a real cert. So basically when that certificate update changes, which takes about a minute, and then it's going to go ahead and start configuring things. here, and then it'll switch across to the PKS. There's a script to do that as well. That tries to be a little bit intelligent at how it does upgrades and stuff. And here is we're managing certificates, etc. So anyway, you can look through those. Let's go ahead and run the pipeline. So that happened, and then we can look at the status of the pipeline. So there's it's running, and then hopefully this logs command here will work. Yeah, so let's just see. Let's just have a look at our pods. Let's just set this to be our default namespace. So you can see there's our first pod running, configure opsman auth, and so that's what we're following here. So that took a minute, and that is now complete. Now, unfortunately, when you do logs like this, even though I'm looking at the labels for any pods in that pipeline, it's gonna break every time a new pod runs. So you can see there's now that completed. And you can see that cert completed pretty quickly as well. So we can look at the logs of that. So you can see successfully applied custom SSL certs. Please allow 1 minute for the new certificate to take in place. And then we can look at the logs of configure opsman IaaS. You can see that is looking at our opsman. All right, we can see the certificate finally changed, and now it's configuring the rest of the IaaS. So again, it's not really anything exciting here to see. If we switch to opsman, we might see it running. So let's go ahead and refresh. And you can see what was our password was it admin password? Opsman password. Wow, what a great password. That's not going to get hacked. So you can see we have Bosch Directive for GCP installed, and we can see our changes being applied here. So this is all, I would say, working as expected. All right, you can see here that first that opsman configure pod has completed. So now let's look at our get pods. You can see it's moved on to PKS, and so we look back at opsman, and you can see here we are. Opsman is configured and installed. The Bosch directive for GCP, I mean. We don't see PKS there yet, so let's have a look at where that's at. Effort. So here you can see we're making sure it's working. Here it's basically getting our certificates and dumping them, and then it's looking to see if PKS already exists. If it doesn't, it's going to download PKS and the stem cell. So you can see that was PKS. You can see it's downloading the stem cell. And then it will upload. It will upload it all to opsman. So that all will take a few moments, and then it should move on to the configuration step. Okay, that is our PKS install complete. So we can kind of roll up and see it all happening. But you can sort of believe me that it's done. And in theory, we should be able to curl one of these and get some sort of response. Probably an empty, yeah. But that kind of shows that it works. I guess we can curl PKS. Yeah, 404, that's fine. Because we need to auth and all that sort of stuff. We can look at Ops Manager. If we refresh, we now see PKS. So there's a bunch of, obviously it's all installed, it's all set up. Our plans are pre-configured. You can see I even have my add-ons in there. And I have 3 plans, but it doesn't really matter. There's the top one's called Basic, so we'll create a new cluster called Basic. So we're done here. We can get our password. I think we already know it because we put in the secret, but we'll just go ahead and run that anyway. And our password is PKS password. So we can run our PKS login and use that PKS password. So logged in successfully. So PKS clusters, we should see that there's nothing there. So we can go ahead and create a cluster. Note I'm using the FQDN here because we're going to create DNS for it once it's nearly done. So we'll go ahead and hit that. Cluster 1. So that's going ahead and creating, and again that'll take a little while. We'll kind of just monitor it and come back in a few moments. Okay, enough time has passed that our cluster should be created. So we can do cluster 1 again. And we should see now it says it's succeeded. It has a master host and it has an IP. That's a private IP, so it doesn't help us too much. But we do have some tooling to help figure it out. So here you can see the DNS for the clusters is not already created, but we can create it by getting the UUID of the cluster and then use that to figure out the load balancer that was created by the add-on that we use. So let's just go ahead and run these to set our environment variables. And we'll make sure that so there's the external IP of our load balancer. So we can go ahead and now create a DNS transaction. So with Google Cloud, you basically create a DNS transaction and then you apply that. So these 3 commands should take care of that. And then we can gcloud DNS record sets with a dash zone list, and then our zone is Opsman. So here you can see the new DNS record for our cluster. Let's just see if that is working. 8443. So that's happened pretty quickly from the look of things. So we should be able to now do a PKS get credentials cluster 1. Was it PKS password? So now we have a kubectl config file set up for our new PKS cluster. So we should be able to do k get nodes. And so there you see our one node. Now my plan just gives us, does it just give us a single node? I can't remember what my plan is. Let's take a look at that plan and make sure it should only have one. And we already have it loaded up here, one master, one worker node. Yeah, so I think for my basic, that's clearly what I specified in my Helm chart. But if I wanted it bigger, I could just do PKS resize cluster. Was it cluster resize? I never remember the direction. Oh boy. PKS. It's just resize. Well, there we go. Resize. And then my cluster num nodes. Let's go to 4. Yes, I'm sure. And then for the cluster 1, it's now 4 worker nodes, and it's updating. So that is our PKS installed on GCP. That is a cluster running, and that is all done via the Google operators to stand up the infrastructure, and then Tekton, which is a Kubernetes-based project, to perform the actual installation work. It's a little bit different to how others install using Terraform, etc. So I just thought I would show it off. Hopefully this has been interesting to you. Bye-bye.